Hello, this week we are going to learn about equal fractions and learn how to compare fractions as far as greater than, less than, and of course equal to. We'll do this by thinking about fractions with the same numerator and the same denominator, and also comparing fractions to benchmark fractions is what we call them. Benchmark fractions are fractions we all know, like 1/2 or 1/2. So to start off with, I just want to make sure that we understand something. I've got 1/2 of a circle here, 1/2 of a circle there, and so this is 1/2 shaded blue, and this is 1/2 shaded blue. But are these halves equal? Is this half equal to that half? I hope we see that these are not equal halves, right? If I like chocolate chip cookies, which I do, and somebody offered me this half of a cookie or this half of a cookie, I would definitely choose this half because I like cookies and this is the bigger piece. So when we are comparing fractions, we have to remember that we're comparing the same amounts. So we're talking about the same whole. Another thing we need to think about is this shaded area of this circle, does that equal 1/2? I know the denominator tells me I need 2 parts. I do have 2 parts. Does that equal to 1/2? Is 1/2 of this shape shaded in? No, it's not, because the key term is equal parts. I need 2 equal parts, and 2 equal parts is roughly there. I'm freehanding this, so I hope you assume that I'm trying to draw a perfect circle on a straight line, but that's not going to happen. So this is 1/2 here. Previously, that's 2 parts, but not 1/2 because they're not 2 equal parts. One thing you'll be asked to do this week is to draw a picture of a fraction, and in a few different ways. So if I think about the fraction 2/3, and I want to represent that, oftentimes we can use just a circle, and I'm going to pretend all of these are 1/3, right? These are all thirds, and I want 2/3 indicated. So I'll probably just shade in 2 out of 3. That's one way to indicate that. Of course, I can do it this way too. And I could shade in these two. Do they always have to be next to each other? No, they don't. This is still 2 out of 3. I could also draw, let's say I've got some marbles, and 2 of the marbles are red, and let's say one of them is blue. Well, 2/3 are red, 1/3 is blue, if I consider that 1 pack of marbles, or the marbles I was given, 3 is considered 1 whole. So this is how we can represent 2/3 in 3 different ways. A simple circle, a rectangle broken up into 3 equal parts, and then maybe something a little different, some marbles, or whatever it may be. Let's talk about making equal fractions. So again, I'm going to use a circle because they're pretty easy to see and easy to understand. So a second ago, we're going to stick with thirds. I had 2/3 shaded in. So I'll do that quickly again. I could use any of these thirds to shade in. So this is equal to 2/3. What is an equivalent fraction that I could use to indicate 2/3 of this? Well, let's see. If I take these lines and I just extend them, notice that I'm not going to be shading in any more blue. I'm just going to extend these lines. So now instead of 3 equal parts, I have 1, 2, 3, 4 equal parts that are shaded and 2 that are not shaded. So now I have 4/6 shaded in. can also do that mathematically by 2/3 times 2/2, which remember this is equal to 1. 2 divided by 2 is 1, so we're just changing the ratio. 2 times 2 is 4, 3 times 2 is 6, 4, 6, and 2/3 are equivalent fractions. I can do one more thing possibly. I could kind of just draw a line through each one of these. Now let's see how many parts do I have total. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I know my denominator will be 12. And it looks like I've got 1, 2, 3, 4, 5, 6, 7, 8. 8/12 shaded in now. But notice I didn't color in any other blue shading. The original shading is still there. I didn't add anything. The only thing I added were a few more lines. So let's try 4/6. And then I cut every pie piece, I guess, in 2, which is like multiplying it by 2/2. I get 8/12, because again, 3 times 2 is 6, 2 times 2 is 4, 6 times 2 is 12, 4 times 2 is 8, and remember when we multiply fractions, we multiply the denominator times the denominator and the numerator times the numerator. This is always going to work, and we draw simple shapes to help people understand and help us understand what we're seeing, or a different way to think about it. But let's do a few more where we use multiplication to create an equal fraction. 1/2, well, let's do something kind of weird. 1/1. What's 1 divided by 1? Well, 1 divided by 1 is 1, so 1 times 1 is 1, 2 times 1 is 2. I didn't change the fraction at all. I actually just multiplied it by 1. So what's our next digit we might want to use? We can use 2, we can use 3, we can use, right? 1 times 2 is 2, 2 times 2 is 4. If I wanted to use 3/3 instead of 2/2, as long as the numerator and the denominator are the same digit or number, this is equal to 1, and that's equal to 1. So we're just changing the amount of parts, but we're not changing the value. 1 times 3 is 3, 2 times 3 is 6. So 1/2, 2/4, and 3/6 are all equivalent fractions. And if you'll notice, each numerator, the same relationship for all halves of fractions is the same. The numerator is half the denominator. 1 is half of 2, 2 is half of 4, 3 is half of 6. I could also think 4/8. I can come up with anything. 10/20 is also equal to half, because the numerator is half the denominator. The numerator is half the denominator. I know we ended the year kind of before we left school talking about decimals, and so this is equal to 1/2 as well. If I have 50 out of 100, the ratio is still the same. 50 is half of 100, the same as 1 is half of 2, the same as 3 is half of 6. So you can always check your work by making sure that whatever the ratio is, it's the same in this case when we're talking about halves. Let's try 1/4. What is an equivalent fraction to 1/4? Well, I can just multiply by 2/2, and that's going to give me 2/8. I can multiply just by 3 now, maybe, and I will get 2 times 3 is 6, 8 times 3 is 24, 6/24, 2/8, 1/4 are all equivalent fractions. Now in this case, I would have to multiply this times 4 to get this. This denominator is 4 times the numerator. This denominator is 4 times the numerator. 24 is 4 times 6, right? 6 times n equals 24. What's the value of n going to have to be? It's going to be 4. So just like in halves, with any fraction that's equal to another fraction, the ratio between the numerator and the denominator are the same. So if I have 25 cents, 25 is 1/4 of a dollar. And so 25 hundredths is an equivalent fraction to 2/8, 1/4, 6/24. If I multiplied by 3/3 here, I would end up with 3/12. Again, these are the same numbers, so I'm allowed to do this mathematically. These are equivalent fractions as well. Why is this important? Well, if you are sharing money, if you're having a birthday party and more of your friends show up and you thought only 3 friends are going to show up and you were going to have 4 pieces of cake, of course 1 for yourself, and you were going to hand out those pieces of cake equally. 4 kids showed up, everybody would get 1/4 of the cake. If 8 kids showed up, you would have to split that up into 8 equal parts, and then in that case everybody would get 2/8 if they were going to eat the same as 1/4. Sometimes we can find equivalent fractions by dividing too, and oftentimes we use division on bigger numbers. So if I multiply 1/2 by 2/2, I get 2/4. If I take 2/4 and I want to make an equivalent fraction, I notice that these 2 digits are even numbers. And so I could actually divide by 2/2 instead of multiplying. 2 divided by 2 is 1. 4 divided by 2 is 2. So just the way we can multiply by 2/2, we can also, in this case, divide by 2/2. Can we take 2/4 and divide by 3/3? No, we can't do that because you can't divide a 3 into a 2 or a 3 into a 4. So I notice these are even numbers, which I can divide always by 2. Let's see, 1/2 times 2/2 equals 2/4. Now if I do this again, 2/4 times 2/2 is going to give me 4/8. So we know 1/2 and 2/4 and 4/8 are equivalent fractions. If I multiply that by 2, I would end up getting 8/16. Let's say I started with 8/16 and I wanted to find a fraction in simplest form or using smaller numbers. Well, I could divide that. I know these are both even numbers, so I can divide that by 2, which is going to give me 4/8. Then I could divide that again by 2/2, and I would get 2/4. I could divide that by 2/2, and I will get 1/2, and that's as small as I can go with the unit fraction of a half. I can divide one way, I can multiply another way. Let's try one more. Let's see, actually I want to stick with this one. 8/16. Well, I know that 16 is a multiple of 8, and 8 is a factor of 16, so I could actually, 2, 2, 2, I could actually just, I know that I can divide this by 8, and I can divide 16 by 8, so I could even just jump to the end right at the beginning. I know 8 divided by 8 equals 1, 16 divided by 8 equals 2. So notice that this is also an even number, and that's going to equally divide into an 8 and a 16. So we can figure out fractions and equal fractions by multiplying. We can do it by dividing. And now let's think about comparing numbers on a number line. Let's see. Is 1/4 less than or greater than 3/4? Well, in this case, we have the same denominator. So I could draw a pretty simple picture here, and I'll draw 2 of these. Notice again that my start point and end point is relatively the same. These are the same sizes. If I have 1/4 up here, and then I have 3/4, we can see that 3/4 is greater than 1/4. We can draw a picture. We can use our reasoning. If I've got 1 out of 4 parts, that is less than 3 out of 4 parts, as long as we're talking about the same amount. So this is where we compare fractions with the same denominator. Is 3/5 greater, equal to, or less than 4/5? Well, if I've got 3 parts out of 5, that is definitely less than 4 out of 5. 4/5 is almost 1 whole, and 3/5 is kind of close to a half. So I'm thinking about my benchmark fraction on a number line. This is 1, or 5/5, and this is 0. So 3/5, every one of these of course is 1/5. Actually that's 3. This will be 2, 3, 4/5, and this of course is 5/5 or 1. So on a number line I can see that 3/5 is less than 4/5 as well. Fractions with the same denominator, the bigger numerator is going to be the bigger fraction. So let's see, 5/6 is definitely greater than 4/6 because 5 is greater than 4, right? That's a pretty simple comparison. This is close to 1 whole. This is just over 1/2. How about 8/10 greater than 3/10, right? If I have 8 out of 10 something, 8/10 of something, that's almost a whole. 3 out of 10, well I know 5/10 is equal to a half. So if I have 3/10, that's less than a whole. This is almost a whole. And so 8/10 is greater than 3/10. Let's talk about fractions with the same numerator. What number is greater, 1/2 or 1/3? Well, here is our benchmark fraction, so we can say, is 1/3 less than 1/2 or is it greater than 1/2? Well, let's see. This one's pretty easy to make on a number line. There's my 3 parts. There's my 2 parts. So 1/3 is here. 1/2 is all the way here. If we're talking about equal parts, and shading in 1/2 is bigger than 1/3. In this case, they have the same numerator, a 1. Two-thirds and 2/5. So I think about 1/2. Well, I know 2/4 is 1/2, so if I have 2/5, this fraction has to be less than a half, and this fraction is greater than a half. So we still have the same numerator. The smaller denominator with the same numerator is the bigger fraction. I have more of this whole than this. I only have 2 out of 5 parts here, so my 2 parts are smaller here than they are here. If I have 2 out of 3, the 2 parts are bigger, and so 2/3 is greater than 2/5. 3/6 and 3/4. Well, 3/6 is actually equal to 1/2, because if I divide, if I divide, I don't write it on that side, but if I divide by 3/3, I actually get 1/2. So what's bigger, 3/4 or 1/2? Or 3/6 or 3/4? Again, same numerator, smaller denominator is the bigger fraction. If I have 3/4 of something, that's right in between a half and 1 whole, and 3/6 is actually just 1/2. Let's do one more. 6/7 or 6/9. Well, again, this kind of rings a bell. I'm thinking 3's here. 6 and 9 I know are both multiples of 3. 6/7 is almost 1 whole. I know this kind of looks familiar. If I divide this by 3/3, 6 divided by 3 equals 2. 9 divided by 3 equals 3. So 6/9 and 2/3 are the same, are equivalent fractions. 6/7 is kind of close to 1. And so 6/7 is greater than 6/9. This is almost a whole. This is just above a half. In fact, it's equal to 2/3, and I know 2/3 is not necessarily almost a whole. So that wraps up the lesson for this week. If you have any questions or concerns, please have your family email me. Again, if you have any suggestions on these videos, I know last week's was quite long. I'm trying to keep them short, but I hope I covered everything here, and have a great week.